All right, so for our online class, January 26th, that Friday, this is, I'm going to do two videos, or two problems in this video. Problem number 17 from page 76, chapter 1, section 7. And then I'm going to turn around and do problem number 25 from section 1.7, chapter 1, section 7. Question number 25. One is a finance problem, one is a travel problem. We'll work, I'll work these two problems, and then for your assignment on discussion board, you will solve one of these problems that's been assigned to you, and you will post that to the discussion board. So you either get one of the finance problems or you get one of the travel problems. You'll be assigned an even numbered problem from the book. You'll solve it, you'll write it all out, you'll post it to discussion board. Either you can type it out in discussion board, would be fine. If you want to write it on a sheet of paper and take a picture of it and post it to discussion board, that's fine as well. But that's your assignment for this, and so every student will be assigned one. This is part of class attendance. Failure to do so will not only have you marked absent for the day, but in addition to that, you'll be walking away from a little bit of bonus points on your homework grade if you'll actually do this. And so I want to encourage everyone to take this seriously and to actually watch the video today, part one of doing the online class. Number two, part two of that is to solve your problem assigned to you and post it to the discussion board. So those two things are necessary to get both credit for attendance on Friday, January 26th, and also maybe a little bit of bonus point for you in your homework. I'll put a little bit of bonus points to those who successfully solve their problem from this section. All right, so let's look at one of the finance problems. This one says that this teacher is investing $16,000 invested, and they're making $1,500 in return, annual return. And we're told that this teacher has $6,000 invested at 7%, and then has another amount of money invested at some different rate. Now, the remaining amount, this is pretty straightforward. If $16,000 is the total amount, and $6,000 is invested at 7%, that means the remaining amount must be $10,000. We don't know the rate yet, but we know how much has been invested. Because the total, these two together, have to sum to $16,000, the total amount that this teacher has to invest. So now, working through the problem, we have $1,500 is equal to 6,000 times 7% plus 10,000 at some unknown rate. We'll call it X. So this is relatively straightforward. 6,000 times 7% is $420 plus 10,000 X. All right, well, just subtracting 420 from each side in order to get the term with the X in it by itself, this will leave us with $1,080. $420 from $1,500 is $1,080. And that will equal 10,000 X. Now to solve for X, simple enough, we divide each side by 10,000. In doing so, that will leave X by itself. So what we find here is that X is equal to 0.108. And that is also known as 10.8%. And that seems to be the answer, is that she has $10,000 invested at 10.8%. She has $6,000 invested at 7% for the return of $1,500 a year on her $16,000 investment. Her $16,000 investment is split into these two investments, this much at 7% and the $10,000 at 10.8%. And the sum of all that return equals $1,500. That's how problem number 7 is done. All right, now I'm going to work problem number 25 for you. Problem number 25 on page number 77 says this. We have a cyclist. This is the travel problem, and we have a cyclist is leaving Las Vegas traveling at 18 miles per hour. We also have a car leaving Las Vegas, as you would imagine, traveling much faster than a bicycle at 45 miles per hour. And the question is, if the cyclist leaves 1 hour before, or if this driver leaves 1 hour later than the cyclist, how long, could ask how far they go, but let's just go with how long before the two of them meet, how long before the car catches up with the bicycle. Okay, so the bicycle, the gentleman takes out at one time, and then the car takes out at another. The question is, how long before the car catches the cyclist? So the bicyclist distance before they meet, 18 miles per hour, times how long they travel, t. Now they're going to meet, and this person is going 45 miles per hour, but doesn't start at t, it starts at an hour later, t minus 1. You see, this is distance, miles per hour times the time, and this is distance, miles per hour times the time, where they meet at the same place. They're equal. They're going to meet up with one another. So we can set these two equal to each other. This gives us 18t is equal to 45 times t minus 1. So solving for this, 18t will equal to 45t minus 45. So we can subtract 45t from both sides. And that will give us minus 45 is going to equal. And then this is a minus also. We don't want time to be negative. It's not time travel here. But 45 minus, or 18 minus 45. And again, you're free to use your calculator on these, but that works out to let's see, that works out to 27 minus 27t. So now dividing both sides by that, t will then equal to 45 divided by 27. 1.6667. Now, that time is the length of time that the cyclist has been going, right? That's how long the cyclist has been going. That's how long the cyclist will be traveling until the car catches. The car started an hour later, so the time that the car traveled, for the cyclist. But for the car, t for the car is 0.6667 hours. That's also equals to 2/3 of an hour. And so that's the time the car travels. That's the time the cyclist traveled until the two of them met. Now the question is, what is it we're being asked for? How long will it take the car? How long will it take the car to overtake the cyclist? So we're looking for time for the car, and that's 2/3 of an hour. If it said, how long has the cyclist be on the road before the car catches them, that would have been 1.1 2/3 or 1.667 hours. And so that's why we got to read the question. Which are they asking about, the car or the bicycle? In which case, in this problem, they're asking how long does the car travel? And remember that the car takes out an hour later. Total time of the cyclist until the car catches 1 hour and 1.6667 hours. And how long for the car itself is 0.6667 hours. All right, so those two problems are sample problems for you. And then now you're going to watch this video and then post on the discussion board the answer to the problem you've been assigned. You have to look on the discussion board. I'll put on the discussion board which problem each person is assigned. Work your problem. You can type it out on the discussion board, or you can write it out like I've done here on the board, take a picture of it, post it in there. Either way is fine, but that's the way you get credit for both attendance today for January 26th, the Friday class, and also the extra credit on your homework that I'm going to give you if you successfully work the problem that you have been assigned. All right, see you guys.